Okay, let's unpack this source. You've probably sat in a math class, right? Staring at, I don't know, the integral sign
Right?
and thought, seriously, when is this ever relevant outside of like this specific room?
Uh-huh. It feels like pure abstraction for such a long time, doesn't it? All those, theoretical curves and areas under them.
Totally. And then, well, then you get a source like the one we have today.
Mm.
It basically throws integration, a core concept from college calculus,
Right.
right into the middle of, well, farm animals.
Yeah, farm animals. Specifically, it links it to understanding the energy dynamics in farming systems.
Which is kind of wild. What's truly fascinating here, I think, is seeing this sophisticated mathematical tool
Yeah.
applied to something so tangible and, frankly, kind of messy. Like
Right.
tracking how much energy a cow or maybe a sheep uses just living its life out on the farm.
Absolutely. It's not a neat, clean lab setting.
Not at all. So the mission for this deep dive is really to dig into this source. We want to uncover exactly how calculus and particularly integration becomes the key to unlocking insights into animal energy use on a farm. What's the core takeaway here? What's the connection?
Well, the fundamental idea, the thing this source really highlights, is that an animal's energy use, it isn't static. It's not just one number.
Okay.
It's constantly changing, throughout the day.
Right, that makes sense. Just think about it. An animal uses energy at like one rate when it's just standing around,
Mhm.
a totally different rate when it's, say, walking to a new paddock.
Yeah, moving.
And maybe an even higher rate when it's actively grazing or perhaps climbing a little hill or something.
Exactly. And you see this a lot in systems like rotational grazing, right? Where animals are constantly being shifted.
Ah, okay. So they're moving, adapting.
Precisely. And the point is, if you want to figure out the total energy an animal uses over some specific time period.
Like during its hours in one field? Or maybe a whole day?
Yeah, exactly. You can't just take a single measurement, a snapshot, and multiply it out.
Because the rate itself is changing all the time.
That's it. The rate of energy use is fluctuating.
Okay, so trying to get a real total by just averaging, or I don't know, picking one speed, it would be kind of like trying to measure the distance a roller coaster travels by just looking at its speed at one single point.
That's a great analogy.
Yeah.
You'd miss the whole picture.
Right.
And this is really where integration comes in. It provides the necessary tool.
How so?
Well, if researchers can model the animal's energy expenditure rate as a function, maybe a function that changes based on activity level or the terrain.
Or even how much grass is there?
Sure, yeah, forage density, things like that.
Yeah.
If you have that rate function, then integrating it over the time interval you care
So
about,
it leaves you the total.
it gives you the mathematically accurate total energy consumed during that period.
Okay. So instead of just making like educated guesses based on averages, you can use this calculus thing to get a much more precise picture of the actual energy transaction sort of between the animal and its environment.
That's the big idea. That's what this source is showing us. It moves us away from just approximation towards a more, rigorous calculation.
And that enhanced understanding, having that better number for total energy, that's valuable.
Oh, incredibly valuable.
Why does knowing that specific total energy number matter so much in, the real world of farming?
Well, if we connect this to the bigger picture, it really impacts crucial management decisions.
Like what?
Like knowing how much extra feed, supplemental feed, might be needed. Or how long they can efficiently graze a certain area before, they need to be moved. The stocking density a pasture can really support.
Right, not just guessing.
Exactly.
Yeah.
And ultimately, it helps optimize things like animal health, their productivity, and even the long-term sustainability of the land itself.
Wow. It's actually pretty remarkable when you think about it, that figuring out the area under the curve for some abstract math function
Yeah.
can directly translate into making these really practical economic and even environmental decisions right there on a farm.
It really is.
So the core insight really is that calculus, specifically integration, it's not just some theoretical exercise stuck in a textbook.
Not at all.
It's actually a powerful tool. It's capable of accurately quantifying these dynamic processes, these changing things in complex real-world systems, like agriculture. And it provides data that's, essential for better management.
And it kind of raises an interesting point, doesn't it? That often the most potent applications of these abstract mathematical concepts, they aren't immediately obvious when you first learn them.
That's a really good point. So what does this mean for you listening right now?
Well,
As you encounter different mathematical ideas or scientific concepts, especially the ones that seem really abstract,
Yeah.
maybe challenge yourself. Try to think about their potential unexpected applications. Where else might a tool that seems designed for one thing secretly hold the key to understanding a completely different system?
It's worth looking for those surprising connections, definitely. What other real-world systems could maybe benefit from a calculus perspective?
Something to think about.